Hello, and welcome to Summarize Science. Self-driving cars are one of the biggest promises of AI, but they face a fundamental challenge that makes them unreliable. Currently, most systems try to learn by looking at sensor data and predicting the car's entire future path from scratch. The problem is, this is an incredibly complex task, and it leads to something the researchers call causal confusion. This is when the AI learns to connect two things without understanding the real reason why they are connected. For example, it might learn that a car's brake lights mean it should also brake, but it might not understand that a red traffic light is the actual cause, which is a dangerous gap in knowledge. Another issue is that predicting far into the future is highly uncertain, which can distract the AI from making small, critical adjustments needed for immediate safety. This paper, titled ResAD, proposes a brilliant change in perspective to solve these problems. Instead of asking the AI, what is the future path, they ask it, why must the path change? The system starts with a very simple baseline, a default path where the car just continues moving at its current speed and direction. This is called the inertial reference, and it's what the car would do if no one was steering. The AI's only job is to learn the deviations, or residuals, from this simple path. This forces the model to focus specifically on the causal factors in the environment, like obstacles, traffic rules, or turns in the road that require a change in course. Essentially, it's not just memorizing what to do, it's learning why it has to do it. The framework also cleverly reweights its calculations, ensuring that small, immediate safety adjustments aren't ignored in favor of big, uncertain predictions about the distant future. To handle scenarios with multiple valid choices, like changing lanes, the system creates a small cluster of slightly different default paths. It then generates an optimal trajectory for each one, giving the car a set of context-aware options to choose from. So, how well does it work? The researchers tested ResAD on the industry-standard NavSim benchmark. On the first version of the benchmark, ResAD achieved a new state-of-the-art score, demonstrating its superior performance. It also set a new top score on the newer, more complex version of the benchmark, excelling across almost all safety and efficiency metrics. This visual comparison really tells the story. Here, a competing model suggests impossible trajectories, like driving straight through a building on a sharp turn, because it relies on a fixed vocabulary of moves. In contrast, ResAD dynamically generates plans that are perfectly suited to the situation. So, to recap the main ideas and what they mean. By shifting the AI's task from predicting a whole trajectory to just predicting the necessary changes from a default path, the system is forced to learn the causal reasons for its actions. This approach, called normalized residual trajectory modeling, makes the learning task simpler and more focused. The results show this leads to safer, more reliable, and more efficient driving behavior. This conceptual shift isn't just a small improvement. It could represent a more robust foundation for the future of all end-to-end self-driving systems. It's a step away from simple pattern matching and a step towards genuine environmental understanding. Thanks for watching this episode of Summarize Science.